What we are focused on more is, we'll say, the mission, manufacturing, producing the electronic parts for the defense sector. We're a consortium of industry members, again, focused on defense sector. And really the number one thing that we do is we cross-connect government with industry to get the work done.
Hello, everyone, and welcome to the Altium On Track podcast. I'm your host, Zach Peterson. Today, I'll be talking with Nathan Edwards. He is the new Executive Director of the United States Partnership for Assured Electronics. Nathan, I've been trying to get a hold of USPAE for a little while, and I'm very happy to have you on today.
Yeah, great. Thanks for having me, Zach. I really appreciate the opportunity to visit with you.
Yeah, absolutely. So we've talked to a few industry advocacy groups in the past. Everybody knows IPC, especially if they're familiar with the alphabet soup of standards. And I think most recently we introduced everybody to PCBAA, or the Printed Circuit Board Association of America. You guys, I don't know if you're new on the block or if you've been around for a while, but I think you are certainly new to our audience. So maybe if you could introduce yourself and then talk briefly about USPAE.
Sure. Yeah. So introduce myself. I do come from a career of electronics industry and background, both in government and commercial sector. A little bit of everything in that mix. From medical devices to military avionics to wearable assistive technology. And really you consider the full stack of electronics, right? You know, we all have to know a little bit about software and other things. So prior to I'll say my predominant government focused work, you know, I left the industry to work at Department of Energy with the National Laboratory System. And then after that, I was involved with one of the organizations in the federally funded research and development centers prior to USPAE. So all encompassing, it's been an amazing journey, amazing adventure in the electronics sector. So let me tell a little bit about USPAE. So we are a little bit different than IPC and PCBAA, although you know, a number of our members, work in these same forums, right? We're predominantly not an advocacy group. If you think about the roles, we need those two organizations out there doing what they do best. What we are focused on more is, we'll say, the mission, manufacturing, producing the electronic parts for the defense sector. We're a consortium of industry members. Again, focus on defense sector. And really the number one thing that we do is we cross-connect government with industry to get the work done. You probably know this, and many of the listeners probably know this very well. When you talk about electronics and those who produce circuit boards, the semiconductors, the other passive components or assemblies and test, many times that's buried so far deep in the supply chain. And so when you get it into a major integrated system, the top level system users and owners don't really know where it came from. Well, we're bridging that gap. We directly connect those who produce, design, manufacture, test all segments of electronics to those in the government sector. And there's a lot of work that goes with that as well. Sometimes it's projects that can flow through the contract vehicle, which we do manage for the Department of Defense, called the Defense Electronic Consortium. So projects can flow through there as a rapid prototype to meet within the DFARS policy. Or the Department of Defense or U.S. government can contract directly with our members. As they have a technology need, and we can introduce them. That's a challenge that the government has with their contract process. They can't necessarily make cold calls out of the promise for a contract. Many of you probably are aware of that. And we get to help with that. And that's been tremendous value, I think, that we offer industry and government, help them shape what the technology might need to be and where they should go from that. So hopefully it gives listeners a broad overview of USP and kind of our role in the ecosystem of all things related.
So this is interesting. You brought up the Defense Electronics Consortium, which sounds kind of like, I don't want to say a marketplace, but maybe a meeting place for folks on the government side of Mil-Aero and folks on the commercial side of Mil-Aero to come together and possibly for one group to find suppliers from the other group. Is that a decent way to describe what goes on in the DEC?
Somewhat. So when you talk about the U.S. government and they have what they call other transaction authorities, it's a way to not go down the long acquisition contract vehicle pathways, which are needed for big systems, right? But for rapid prototyping or things into limited rate initial production, LRIP, these other transaction authorities are ways to accomplish that fast. So there's a number of consortiums out there that are managing these contract vehicles on behalf of the federal government. And so we call them consortium, but you're right, it's a kind of a meeting place. It's also a way for the government to flow rapid contracts through.
I see. So I think this is interesting because if you look back at the history of electronics and science and technology generally, a lot of the best known commercial products actually started as a defense project and then later got commercialized. Is a lot of the work that's flowing through DEC and some of these other consortia eventually going to go that route? And is this maybe a great way for like startups, innovators to try and connect on some of these projects and eventually build out a new commercial product?
Absolutely. I mean, this is one of the debates, right, of how, or the role of government in their investment into industry or to get the things that they need for the defense sector, for commercial sector, homeland security, et cetera. In investing in the small businesses, the medium businesses, really we get a lot of technical innovation coming out of these bright minds. Sometimes they're very niche areas. Sometimes they're big corporations that deal with this. But these consortiums allow a way to make that happen fast. So let me give you an example. The government may opt to have a short white paper, for example, as the call for proposal. And out of that short white paper, a short review cycle, it's lower burden for the government. It's lower burden for small companies to participate. And then they can make a contract decision based on that. If you go down the normal process, a call for proposals, well, you could be looking at a 50, 100-page proposal, and it's very lengthy, time-consuming to review. Yes, we need that, again, for major systems, but for these risk-reducing prototypes, smaller modular systems, things where our technology industry companies in electronics can move out fast, you may not need that overhead burden. So that's where these consortiums really come to play. So yeah, getting back to your question, I think it's a great opportunity for small, medium companies to participate in the government ecosystems, to get involved with that, to field their products. And yes, part of that is fielding dual-use technology where they have a commercial pathway as well. And I think that stimulates a lot of things in the United States. So pretty exciting ways to accomplish business for sure.
Well, I think this is important because given the makeup of the U.S. side of the PCB and electronics manufacturing market, and you look at the allocations towards commercial versus military, I think it's inevitable that a small design firm might have to pursue some of that business in order for all of their activities to really pencil out and to be able to pay, if you're a business owner, to pay yourself as well as your employees. So I guess the first question that kind of arises from this is, how much does the defense sector make up for the U.S. electronics manufacturing and engineering market? And the follow-on to that is, if you're a small business, do you need to pursue that if you're maybe an individual designer or small design firm operating in the U.S.?
Yeah, that's a great question. Let me start by answering this from a top level perspective, just technology manufacturing in the defense industrial base. So a colleague of mine co-led a study a few years ago that interviewed 649 manufacturing firms in the defense industrial base. And the results were 86% of those firms receive less than 10% of their revenue from defense. Yet those companies make items that are critical to our national defense. Now, I don't know the specific numbers for the electronics segment of the defense industrial base, but my guess is it's probably pretty similar. However, the flip side is we have a lot of small companies and medium companies, even some of the large defense primes that do some really neat things. And so if you consider that for the small companies, that if a small portion is tied to defense, they need to stabilize their own revenue streams with commercial sector. The flip side is if those companies have a focused skill set on tamper protection, security oriented, cyber, you name it, right? That's very niche area, and that really is defense sector focused. And we got some great firms that deal with that in the United States. And so their dependency on defense spending on contracts is much higher than the broader sector. Again, really what it describes is a lot of dynamics to be considered. And in the end, really, our national defense sector is what really protects the freedoms we have in the United States, including the electronics industry innovations, the markets, and so forth. So while for those firms where this 10% revenue might be defense, the impact of our electronics industry and technology offerings is really, really large, for all of our society in the United States.
And I'm sure if you're a small business trying to get into this area, it's number one, a good hedge against commercial business fluctuations, especially if you can get in with a large prime and start getting line items on some of their contracts. But also, I'm sure some of those skills and some of the innovations that you come up with in building some of these products for the defense base, they very easily translate over to what you might need to do commercially. And you can probably come up with some interesting solutions that folks in the commercial sector might not think of.
Yeah, absolutely. I mean, okay, if we take defense sector ideas, concepts, I think the banking and finance industry has some very similar needs. Got to protect the cash flow in the banking environments, right? And that goes electronics technology to cyber and software and, kind of the whole gamut of things. And you could say the same for other critical infrastructure sectors as well. Energy, transportation, we know some of the challenges in transportation environment. There's been some horrific incidents, of course, related to avionics as well. But again, all these secure kinds of concepts and technologies that we see in the electronics industry and the defense sector also apply to that. And it's not just security, really. I mean, we could say high reliability environments as well.
High reliability was what I was thinking, but you brought up like tamper proof, which I should have gone to first because we've talked with a well-known hardware hacker named Joe Grand in the past. And he brought up all sorts of interesting ways that people can probe devices and eventually hack a piece of hardware and bend it to your will or extract the data from it or whatever you want to do with it. And he brought up infrastructure as one of the big ones, but you brought up banking. And that was something I think most people don't think about. It probably seems like this kind of black box industry. Why would they need electronics aside from, servers and computers? What else do they need as far as, tamper-proof electronics? I think one of the things would be like hardware security modules. But are there other things that maybe we don't know about?
Well, I think we know about them, but let me highlight a few.
Okay.
In the cryptocurrency domain, it's really interesting, right? Now, I say interesting because we have a lot of criminals in that domain. Crypto mining activities that are happening in countries where the electric power costs are low, and they set up these server farms to do the crypto mining. It's a very expensive total operation if you think about the cost of electricity. So that's one use case, right? But it boils down to protecting a crypto key of some sort or some electronic transaction asset. The same goes into our consumer economy systems. We have our credit cards now have these crypto chips. For a transaction to occur, you got to have the same communication handshakes. You got to authenticate. You have to do all these things that happen where the consumers don't really see that, but it's all baked into that new technology. both the point of sale terminals, the cards, the backend infrastructure, and it all requires security, authenticity, and some reliability and recovery mechanisms. Otherwise, your electronic assets, could potentially disappear, and that would be bad for all of us.
Yeah, definitely. We hear about it a lot in terms of, I guess, hacks on exchanges, but you don't hear about it from the other side that you just brought up. And actually, you just kind of internationalized the discussion a little bit by bringing up, setting up these server farms in other countries where energy costs are lower. And so that's, I think, a good segue into my next question, which is we've been talking about the US side of it and like a US Defense Electronics Consortium and other consortia. But is there a similar model in, let's say, in Europe or in the UK, maybe Australia, some of these other parts of the world?
I believe so. And so, and we're talking the public-private consortia type of model. So one of the ones that sticks in my mind is the Fraunhofer Institute in Germany. They do some really neat electronics innovation, some manufacturing. They have industry participating in that institute as well as government to kind of push the boundaries of what's needed for the European Union and kind of those regions for advanced electronics manufacturing and so forth. And that's kind of a neat one. I mean, there's others in the UK as well that are, again, are those public-private partnerships to push and advance the electronics sector forward. So, yeah, I think we see these at USPAE. We don't interact with many, but there are a few out there that we're aware of, and they're great models. Again, where the government shouldn't pay the bill for everything, right? This has got to be a whole of economies and industry participation as well. But sometimes, those stimuluses are needed to reduce that risk for industry to carry forward and do some amazing things.
Yeah, you're talking about stimulus to reduce risk, and I guess the other side of that is to maybe spur some private investment, because when you see that maybe there's some public buy-in, there's more likely to be some private buy-in, and I guess that's really the model under which the CHIPS Act was passed. And so we're seeing that for semiconductors, but we have yet to see something similar for PCBs, at least in the US. And I don't think we've seen anything like this outside of the US passed just yet. I know that there's a European CHIPS Act, but European audience will forgive me. I don't really follow what happens with European politics so much. But I think overall, bringing up these incentives to try and spur reinvestment in a diversified manufacturing base makes a lot of sense. What other policy dynamics are available to help spur that investment by individual companies and by innovators? Right.
Well, let me talk briefly about a recent policy change. And this is from a few months ago. The President of the United States officially issued the determination for printed circuit boards and substrates to be one of those categories that the Defense Production Act, Title III, can fund activities. And that's exciting because it says, hey, our country has a critical dependency on printed circuit boards, substrates, et cetera. And we kind of know this. And my colleagues at PCBAA have a nice tagline, chips don't float. And that's true. In order to field advanced electronics, you need everything. You need the solders, you need the board substrates, the advanced packaging, as well as the semiconductor and new architectures that are coming out of that. So with the presidential determination, and the Defense Production Act Title III authorities, they can opt to fund activities, and they could also offer what I seem to remember, some loan guarantees. Again, other things that will help reduce that investment risk by private investors, and as well as stimulate, the activities in the United States. So the DPA office is tremendous folks to work with. They really keep aware of many things that are ongoing. But again, with that presidential determination, it will open the door to help with that stimulus, whatever it is, whether, like I said, direct funding, loan guarantees, et cetera. I can't remember all the categories that they have in their authorities to offer, but it does have the possibility of helping industry and investors, private investors, make things happen pretty quickly. Again, with the goal of reducing that risk. So in the United States, we have what we need to be more self-sustaining. And we're one of the largest consumers of electronics and technologies in the world. So
Well, yeah, I think it makes sense that, some of it get made locally, and you could probably take that same idea and telegraph it over to the European markets, and it probably makes sense for them to produce some more of their stuff locally. I think one of the challenges with this, though, is that when you start to look at what companies are actually doing, especially the really big names like Apple, it's not full on onshoring of some of the production capacity that you would have expected when you hear the word onshoring. I mean, yeah, you have, the semiconductor industry investing a pretty significant fraction of $1 trillion in semiconductor production, but the whole chips don't float tagline really brings up the point that you have to have all the other stuff too. And I don't see a lot of evidence that all the other stuff is getting onshored to the same level, right? I mean, India, now is participating with Apple in iPhone production and assembly. If you hear the word onshoring, you would have expected it to be in, Illinois, not India, right? So I guess that brings up the question. I mean, of all this other stuff in the supply chain, how much of it can you really expect to be onshored? Because so much of it is driven by price. And if you can go to Vietnam for lower expense than you can to Virginia, isn't this really just going to be a broadening out in Southeast Asia and not necessarily into the US?
All great points, Zach. I mean, if you watch some of the online posts or articles that are happening in the electronics industry, you see this shifting of dynamics, right? Everybody's concerned about the Asia Pacific region, really moving operations away from China, and of course Taiwan potentially being at risk, although Taiwan has some tremendous manufacturing capabilities. But yeah, if they go further south in Asia, those are certainly some options. India, Australia, but really, if we step up a level, what are the drivers for this? If you go back about, I might have this wrong, about 4 years ago, when the former president put in some policies and tariffs with imports from Asia, we saw those dynamics change because some of the tech companies in the semiconductor domain, it's $1 million a day lost revenue if they have to pay tariffs or they have reduced production. And then the pandemic hit, and we see these same challenges from a lack of diversity in supply chain. And so that still is on everybody's mind about that. So the diversification needs to obviously consider costs. Lost revenue for some companies is a big deal. Location and kind of that reliability of that supply chain. And that includes natural disasters as well. I mean, obviously, in the United States, we're seeing a lot of that with weather changes and climate. Other countries are observing that as well. So all those elements go into a calculus of how to reduce risk and where you need to plant your supply chain and manufacturing base. In the United States, we still have huge need, right, for our critical systems, let alone all of our consumer iPhones and laptop computers, which are tremendous, right, as we're trying to close the digital divide in our country. There's a lot of dynamics that companies have to make. And you brought up the example of Apple. What they're doing, their calculus may be different than some of the semiconductor companies, may be different than some others as well. The good news is that we are seeing stimulus, with CHIPS Act and other initiatives to build onshoring partnerships. So one of our member organizations is in the semiconductor packaging, or OSAT domain, and they've struck a partnership with their local state government that if they get some CHIPS funding, the state government is going to kick in several $100 million to help with that investment because it builds workforce, it builds technology base, it builds this ecosystem in that region. And we see that in other places in the United States. That is exciting. I've also heard some initiatives in Canada and also Mexico, so it considers all of North America as well. So a lot of dynamics, exciting times to be in. And but we do hope more onshoring in the United States, at least to support some domestic needs for our critical systems.
So there are a few great points here that I'd like to pick at just a little bit. But one point here regarding onshoring is, I mean, it's no secret, people are looking at onshoring in order to diversify geographically their manufacturing base away from being heavily centralized, mostly in China. My suspicion is that it's not necessarily going to reduce a dependence on China, just necessarily change most of what gets manufactured in China, specifically with regard to electronics. So maybe the more heavily IP critical stuff, maybe more of the critical infrastructure, military kind of stuff comes back on shore in different areas of the world, whether it's Europe or the US. And then more of the consumer products kind of get scaled out and you have higher volume of those going into China. So I don't think this necessarily hurts China per se, but it just kind of shifts what they do a bit. Would you say that's a fair statement?
Well, maybe. So there's a policy dynamic that will go into effect in 2027, and this is under the National Defense Authorization Act. So two things. Number one, semiconductors have to have some traceability on where they're produced, and so the law it doesn't go into effect until 2027 for enforcement, that semiconductors cannot be produced by some of the companies in China. Same thing goes for printed circuit boards and interconnects as well. So that will mean a little bit more of a hard boundary of what the U.S. government can procure. So then it begets the question, well, how much market share or consumption of electronics technology does the U.S. government have? I don't know what that number is, but I suspect it's pretty high if you think about all the computers that the government buys for day-to-day operations, the cell phones, the communication systems, the radio systems, just all the things that go into our critical infrastructures that the government has some ownership of. So I think those changes will be more significant than just a minor shift away from China. If you go to the commercial sector, they're probably more concerned about reliability of their manufacturing base. And I'm not sure, again, I'm not a politician nor a global policy expert by any means. I'm an electrical engineer and tinkerer at heart. So, but I hear though that in China, the government there is also considering enacting certain policy changes. So maybe this is something of a trade war. I don't know if that's the appropriate terms, and but when we see a bifurcation of policy changes, there's going to be some dropout, and I think this is what commercial sector in the electronics industry are worried about, right? Again, they want to produce their parts, generate the revenue. In the defense sector, we want reliable parts, trustworthy parts, and availability. So we'll see what happens in the upcoming years on that. But I think all need to kind of shift and be mindful of this and how we set up or establish new partnerships and where, I think is going to be important.
Well, speaking of where you set up those new partnerships, we've had some folks on the podcast talking about production in Latin America. So we've talked with one smaller EMS company CEO who has operations in Taiwan as well as in Colombia. And then most recently, we talked with a supply chain consultant who was actually in Mexico at the time we were talking to him, looking at the manufacturing base down there. So these are not the first two people I have heard bring up Latin America as a great place to produce electronics. What are your thoughts on Latin America and specifically Mexico for electronics production? And what do you see as some of the challenges?
Sure. So, almost 20 years ago now, I was in the medical device industry. I was very aware of some of the electronics production was already occurring in Mexico. Same can go for the automotive industry. And computers and et cetera. Mexico has always had some partnerships with the tech base in electronics for manufacturing. Now, that's probably wax and wane. I haven't, again, tracked the numbers on that. I think from a North America perspective, North America first, and what we have, in joint forces with militaries in Canada and Mexico as well, I think it's a great perspective to think about. With labor costs, manufacturing costs, it's driving distance if we really needed to truck things versus fly. And you get down into other parts of Central America. Here's the one thing I don't know how it'll play out. China is investing in foreign manufacturing also in Central America in the electronics sector, and as well as South America. So when we think about that National Defense Authorization Act of policy, where it says, certain things can't come from China. Well, how about their subsidiaries in Central America? How does that play out? I don't know, but it's something to track for sure. Again, the challenge is that some of these countries do have some socioeconomic challenges in front of them. And so to bring up a manufacturing base, industry will have to own a key part of that to make sure they deliver reliable and quality goods coming out. If you understand the socioeconomic issues and as a culture, where are you going to get your workforce? Who's going to sustain that? The mindsets that everybody has going into that. So there's, I think, some challenges in front in some of the countries, but I think North America is a great opportunity to, again, think about.
Yeah, one of the points that was brought up also is that it's close to two oceans. So if you produce there, you can immediately ship out to external markets in Asia as well as in Europe. So it's nicely located there. Obviously, if you're a U.S. company and you're buying from, let's say, a Mexican EMS, or you have a captive operation in Mexico, you brought up a great point. It's in driving distance into Texas. So it seems like a pretty obvious place to produce. You then brought up the other point, which was Chinese investment in Latin America. And so I'm just wondering if we're then going to see like JLC PCB open up, a factory in Puerto Vallarta or in somewhere along the border so that they can get some of that American business.
Right. So that's something that our policymakers in the United States have to really put some thought behind how to execute these challenges. Again, when you think about foreign influence kinds of questions and national security questions, all things of concern. I personally would like to see a lot more happen within our borders, within the United States. On as volunteer duty, I mentor a number of emerging talent at the high school, middle school level with some of the school districts and others. I'd like to see them more involved in the electronics sector, but if you think about career pathways, it kind of needs to be regional. It needs to be in the United States for them to be exposed to that. As they think about new innovations, let's say their career pathway says, hey, they're going to be in the design domain. The United States leads electronic design for many, many sectors, right? If they want to be the design, well, they kind of need to know how they're built. They kind of need to see it maybe, or have hands-on experience of creating. And so all this says, again, the ecosystem for career pathways, for next generation STEM talent, we need to have a lot more here in the United States.
Well, I would agree with you 100%. This gets back to another point you mentioned earlier, which was workforce. And this is already it was already a chronic problem in the electronics industry, and specifically in the US. And it was projected to become an even worse problem going into the future. Now it seems like you have all this stimulus, specifically in the semiconductor sector, probably going to be new investment in the PCB side and in other parts of the supply chain. And there's already a labor issue pretty much across the economy in the US, and that's only going to get worse. And I think when kids take a look at technology, specifically like software, because let's be honest, most kids, when they hear technology, they think Google, Facebook, that kind of stuff. When you think about the technology competition in those areas, looking for talent and workers, how do we compete? what do we do? I love that you're mentoring young people, and I think that's great. And I would love to do more of it. There's actually someone that I mentor as well. Um, but man, how do we scale that? How do we reach the kids and really show them that like this is a cool area to work in? And oh, by the way, you can do software too if you work in the electronics industry.
Yeah. Well, I mean, the electronics industry requires the full depth of STEM career fields, right? We need the chemists, the chemical engineering, the manufacturing engineers. We need the mathematicians. We need the electrical design folks, and the whole gamut, right? Anything you want to do in STEM fields, you can do in the electronics industry. And so that's one thing that a lot of younger students, even in college, don't understand or appreciate. You don't have to go down electrical engineering pathway to be participating in the electronics innovation. And so there's an awareness challenge I think we have in front of us. Um, Now, just 2 weeks ago, I presented a conference paper at the American Society of Engineering Education. You can see in my LinkedIn post that, but rethinking the electronics workforce development, and really kind of push that boundary of, well, let's get these students, younger students in secondary level, so the middle school, high school, introduced to electronics sector. What is it? What's involved? All these STEM disciplines, number one, but even going through design cycles or creating or soldering or solving a real world problem with electronics tech, but then they have to think about the mechanical placements and enclosures. I mean, it's a lot of fun to see their bright minds go at this. But what we found, and I had 4 high school co-authors on this paper, they were also participants in the case studies. They said, hey, we had no idea that this is what the electronics industry, or what's included in the electronics industry. We didn't know about career pathways. We didn't know that you could start learning this stuff in high school prior to college degree. We didn't know, and you could fill in the gaps, right? And so I think that awareness campaign is going to be really important. And then if you consider the diversity and inclusion topics, we have even a broader challenge, right? So how do we reach those different groups of diversity and inclusion groups, or the socioeconomic demographics too? The Title I schools that really don't have access to the technologies or those topics, right? Each of those groups is going to require different strategies to recruit them, to train them, educate them. Even if they don't work in the electronics industry long term, their familiarity will stimulate more innovation in the United States. So we have a big task in front of us for workforce, for sure. Scale, how do we do that? I'll start with a grassroots effort. We need more volunteers like you and I, just jumping in and doing and mentoring. Any opportunity we have to encourage the younger folks, whether it's college level, high school, middle school, etc., let's do it. I was told by a senior leader in government last December at a defense manufacturing conference, said, hey, where are my unicorns, is what she was asking our little forum there. They need more unicorns like us out in the community to get started. Now, to have a national strategy to execute that, that'll be more of a challenge because, again, each of these demographic groups and the inclusion diversity groups have different needs of learning and introduction of topics in electronics. So, but we all got to start working it. All of us need to own it. If we're in industry already, which you and I are, where are we going to get our next employees? We have to grow them ourselves. And that is always worth the benefit for, we'll say, life as well as the workforce that we need.
Yeah, I think this is one of those areas where public buy-in at some level is needed, because if you look at the current leader in electronics manufacturing, which, Taiwan and China, there was a lot of government buy-in early on that helped propel all of that to the point where it is today. And it seems like we've just totally lost that over the last 20 years. I know that at least when I was younger, there was a lot of focus on computers and, learning how to use computers and eventually programming and networking and things like this, really the basic stuff that was going on 20 years ago. And I think that helped contribute, as well as elements of what happens in pop culture, to the situation we have now where, technology is just directly equated with software. and everyone kind of looks at the PCB as this, overblown way to connect your computer chips together. Um, so with that public buy-in going on, does that need to be really a local thing that is like a, public-private kind of partnership, almost like a microcosm of the Defense Electronic Consortium, but focused on education?
I think it does. So, the when you and I were growing up, we had what they called vocational education in the high
Mm-hmm.
school, right? Uh, the AutoCAD drafting was probably pretty new. We had blue lines. You could do that. You could do shop. You could do a couple of other areas, right? Now what they have is called Career Technical Education, CTE. So that's usually sponsored under the State Department of Education as well as the Federal Department of Education, and how they execute. There's a number of topics that each school district can decide that they want to focus on, whether it's biomedical tech, STEM, IT, and they still have construction trades and some other things as well. In order to make that happen, yes, you need industry participation in that education ecosystem. The schools need guidance on what's going to help train these high schoolers to prepare them for different work and career fields. We could say the same for electronics industry as a broad perspective. Everybody has to participate. But here's the challenge, though. The educators don't really know what we need in industry. And so we have to help them to get there. They may not even know how to develop curriculum. Now, there's a couple of curriculum packages that are out there for the career technical education. Some are good, some are mediocre. I'll say a lot more on the mediocre side because they teach just basics. Hey, what's a LED? What's an Arduino? And which, Arduino training goes to programming instead
Mm-hmm.
of developing your own. What's a battery? So they get to the basics, but they don't actually bridge the gap and go further into, well, how do you create something new? How do you design a board? Which they can do. And I've mentored a few that have done some pretty neat designs. And so with that public-private partnership, it really has to span, across each region, industry participation, the schools. But we also have to be knowledgeable on how this can help meet the education goals that high schools are under pressure to meet with the No Child Left Behind, with their common criteria, accreditations they have. They have funding that's tied to that, which means teachers, they have to pay the teachers to make things happen. And then, so it ends up being that the teachers don't have time to develop as much new curriculum. Some take an amazing job, an extra effort to do that. But again, this is something where industry has to participate. Now, probably at the state levels and national levels, we got to help inform them about these STEM career field needs. You and I are biased towards electronics, but I think it really broadly applies to all STEM fields. But again, you're right, Zach. It's got to be a partnership to make it happen so that we can directly transition new folks coming into the career fields. And it doesn't have to be at the college level. I'm sure there's probably going to be some post-secondary education, whether it's a technician in the high-tech skilled fields or designer. Again, some of these things don't require college degrees, but they do require more education. So again, how do we help people along in these different career pathways, which ultimately helps us in our massive electronics workforce gap that we have in the
Yeah.
United States?
I'm a firm believer that if you hook the kids early and get them passionate in that kind of preteen, teenager kind of phase, that you're going to get someone solidly involved in STEM by the time they're in college, instead of just going into college to get the piece of paper. They're going there because they're passionate about something. So yeah, I agree. Earlier is better. More public-private kind of partnership. I don't know what that looks like, but I think that's going to be really critical for us in the PCB industry and in electronics more broadly to really succeed and build up that workforce in the future. We're running a little low on time, but one thing I wanted to get your take on, seeing as how you are part of a group that interacts with manufacturers and designers, what are manufacturers telling you that they need in order to do things like onshoring, in order to do things like build the workforce, in order to do things like upskill their workforce so that they can bring and invest in these more advanced fabrication and assembly capabilities, whether it's in the US or a captive operation that's nearshored?
Yeah, I'll say two topics seem to come to the top of my mind. Workforce is one. Um, Finding and retaining your workforce is a challenge. And you talk with some of the electronics manufacturers that are in rural America, as well as those who are in populated Southern California. It's the same kind of workforce challenge, finding and retaining. So how do we help them along? And I think part of that, again, goes to our immediate prior conversation on the workforce. How do we encourage, excite folks to participate in that? The next topic that comes to mind really on the challenges that we hear is capital investment. And not necessarily money, but we're talking towards manufacturing equipment that can produce state of the art or even state of the practice that's not in the United States. Ultra high density interconnects, for example. We can't produce at scale 25 micron line in space. Typically, those get shipped out overseas to Asia or Europe for production. But companies can't necessarily spend, $30-100 million to build out a new line when they don't necessarily have a domestic demand signal for that. And so what is that domestic demand? Is it coming from the defense sector, commercial sector, medical, critical infrastructure, right? So those are some of the gaps that we hear that they're struggling with. And so we get to help with some of that, on trying to understand the demand signals, help them bridge that, and if they are a privately held or publicly held company, they'll have to report to their own investors on that, but they can't make that step, that leap of that capital investment towards new equipment unless they have demand signals. So now it goes back to that risk reduction effort that we talked about early on in our conversation. So again, those are the two things that really come to mind: the capital investment for equipment and then workforce.
Okay. Persistent challenges echoed by others who have been on the show. So I definitely want to thank you for that perspective. So to everybody that's been listening, we've been talking with Nathan Edwards. He's the Executive Director of the United States Partnership for Assured Electronics. If you're watching on YouTube, make sure to subscribe. You'll be able to keep up with all of our episodes and our tutorials as they come out. Make sure to check out the show notes. We've got some great links there where you can learn more about this important organization, and you can get some great resources, including the paper that Nathan referenced in our discussion. And finally, don't stop learning, stay on track, and we'll see you next time. Thanks, everybody.